as a function, we call it f of x. We all have learned this in our 7th grade year or even 8th grade year, and we all think this is a very simple equation. However, this actually is not. This is the very fundamental equations in calculus, and a lot of calculus ideas expands based on these equations. So let's do some recap on it. First, to get the m of x, we all know that we have to plug in 2 points on the graph, and we do rise over run, which plug in y2 minus y1 and over x2 minus x1, and then we'll have the m of x. And as for the b, we'll just do linear equations with another point on the graph, and then we'll have the b. This seems to be quite boring, so I'm going to spice this up a bit. Let's say I have a graph here, and I have 2 points. This point, I'm going to mark it x. However, this point, I'm not going to mark it x2. I'm actually going to make the distance between this point to another point h. And the upper point here will become x plus h. And we know that f of x is basically just y, but in a different form. So we're going to do f of x plus h minus f of x over x plus h minus x. And after some subtractions, x minus x, they cancel out. We're left with h on the bottom, and nothing changes on top. This very simple equation you see here, well, not so simple maybe, is called the general difference quotient equation. And this is something very, very related to the derivatives in calculus. So let's work on some example problems. Let's say I have an equation called f of x is equal to 2x squared minus x plus 3. And the f of x plus h is basically substitute x plus h into the x. So f of x plus h is equal to 2 of x plus h squared minus x plus h, don't forget to put in the bracket, plus 3. And let's expand the equations. 2 times x plus h squared is x squared plus 2xh plus h squared minus x, and minus h because negative positive equals negative, plus 3. And now we have it. And now let's do the next step, the f of x plus h minus f of x. Don't forget to put in a bracket. And so 2x squared minus 2x squared, they will cancel out. And then we'll have 4xh after it. And then we'll also have the 2h squared. And then negative x plus x will also cancel out. And then we'll have negative h. And the 3 will minus 3, so they will also cancel out. So now let's do the last step, which is f of x plus h minus f of x over h. So 4xh plus 2h squared minus h over h. And we can see that in the 4xh plus 2h squared minus h, they all have a common factor called h. So let's factor that out. And now we're left with 4x plus 2h minus 1. Okay, so next let's talk about the very important part of calculus, which is called factorization. Factorization has many different kinds. The first very simple kind is just x squared plus 6x plus 9. This one will be factored into x plus 3 squared. The reason why this is like this form is because the one at the end, at the third term, is a square of a number, and the first one is also a square. And the second term is just basically the combination of these two terms and then multiplied by 2. So this will become x plus 3 squared. The second form will be something a bit trickier, which will be like this. X squared plus 7x plus 12. To factorize it, we first have to see the last term, 12. And so to factorize, we have to find two numbers that will multiply and equal to 12, but at the same time they add up to 7. So one number's multiplied to 12 but equal to 7, but add up to 7. You can stop this video and think about it for yourself. And the answer is actually x squared plus 4x plus 3x. 4 times 3 is equal to 12, and 4 plus 3 is equal to 7 plus 12. And the next step we're going to do is actually just plug in x plus 4 and x plus 3. And here you go. You factor it. The next one is more trickier than the first two, in which we now have a coefficient. 6x squared plus 11x minus 10. To factorize these, we first have to multiply the first and the last coefficient. The first term's coefficient and the last term. So 6 times negative 10 is equal to negative 60. And this is very similar to the thing we just did. We have to find two numbers that will add up to 11 but multiplied to negative 60. So let's try it out. 1 times 60 is equal to 60, but 60 can plus or minus 1, they can never make it to negative 11. And let's try 2. 2 times 30 is equal to 60, but 30 plus or minus 2, they can never make it to 11 as well. Let's try 3 then. 3 times 20 is equal to 60, but 20 plus or minus can never equal to 60 as well. And let's try 4. 4 times 15 is equal to 60. Wait, 15 minus 4 can be negative 60. So what we're going to do is just 6x squared plus 15x minus 4x minus 10. And now let's factor it. We'll first separate this into two terms, and then we're going to find a common factor between each of them. So 6x squared and 15x, they all have the x, and they all are a factor of 3. So we're going to say 3x, and 3 times 2 is 6, and we have one x left out. So 3x, 2x. And 3x plus 5 times 5 is 15. So 3x and we have 2x plus 5 in the bracket. And negative 4x and negative 10, they all have a common factor of negative 1 and negative 2. So negative 2 and 2x plus 5. And now we're going to combine these two terms together, become 3x minus 2 and 2x plus 5. And here you go. So next we're going to talk about something similar in which this might be easier, but this might be harder. We have something like this: 49x squared minus 64, and we have to factor it. First, you can pause this video and see if you can figure something very special between these two numbers. And the very special thing about these two numbers is that they are all the square of some numbers. 49x squared is the square of 7x. 64 is the square of 8. And so when we find that out, we can do 7x plus 8 and 7x negative 8. And here you go. The hard part of this is to figure out the square, and the easier part is just how simple it is compared to anything before. And next, let's talk about the hardest in factorization, which is the cubic equations. Let's say I have something like x cubed minus y cubed. And the general equations of this is x minus y and x times x squared plus xy plus y squared. And while doing cubic equations, you have to first figure out what is the x and what is the y. So you're going to square root this you're going to cube root this. And as for x cubed plus y cubed, you're going to do the same thing, figure out the very basic form of the cubic, and then you're going to do x plus y times x squared minus xy plus y squared. And the next important fundamental of calculus is rational function. Rational functions means the quotient of two different polynomials. So rational function means the quotient of two different polynomials, which means f of g over f of h. And there are several important components in a rational function. The first one will be vertical asymptote. The second one will be the horizontal asymptote. And the third one will be hole, or a removable discontinuity. The fourth one will be zero. So let's briefly talk about each one by one. A vertical asymptote means, in a simple way, means there's a vertical line on the graph, and when the function wants to approach it from the left or right, it will be very, very close to that vertical line but never touches it. And same for the other side. A horizontal asymptote serves the same purpose but horizontally. A function will be approaching it very, very, very close to the x-axis but never touches it. And a hole or movable discontinuity means that at a certain point in the function, the graph doesn't exist because we have a situation called f of x is divided by 0, which we all know that this doesn't exist in anything. And 0 is the 0 in a normal factorized equation, which is when the denominator part equals to 0. And the denominator part will be any number but not 0. Here we have a rational function called 3x squared minus 12 over x squared plus 3x minus 10. Usually when we see some problems like this, we'll want to factorize it to give us a clearer picture. So let's do it. On the denominator part, we can see they all have a common factor of 3, so let's factor that out first. 3, and then we're left with x squared, and 3 times 4 is 12. And on the bottom part, x squared plus 3x minus 10. So what multiplies to negative 10 and adds up to positive 3? Pause this video if you want to give it a try. The answer will be x plus 5 and x minus 2. Because 5 times negative 2 is negative 10, 5 minus 2 is 3. However, we're not done yet. On the denominator part, we can actually further factorize it into x plus 2 and x minus 2. Because x squared and 4, they're both the square of x and 2 respectively. So it will become 3 times x plus 2 and x minus 2 over x plus 5 and x minus 2. So now let me copy this onto the side. 3x plus 2 and x minus 2 over x plus 5 and x minus 2. So now let's start to identify the components in this function. So here we can see that x minus 2 can be cancelled out. And so this becomes the removable discontinuity, which means that at a point when x is equal to 2 and some y value, we'll calculate that later, the graph will not exist because this function is divided by 0. So let's first get that part first. To get the y value, we'll sub in 3 times 2 plus 2 over 2 plus 5, in which that will become 2 plus 2 is 4, 4 times 3 is 12, 12 over 7. So at point 2, 12 over 7, the graph doesn't exist. So now we are left with the horizontal asymptote and the vertical asymptote as well as a 0 to identify. So now let's do the vertical asymptote first. The vertical asymptote is when the graph, when there's a straight line touching the x-axis, in which that makes all the graphs, all the functions try to approach it, never touches it, but very close to it. So that means it has to be on the denominator part because this also has to be 0. It has to be touching the x-axis, which becomes a 0. And here we can see that the x plus 5 is on the denominator part. So and we want to make it to 0, right? So the vertical asymptote will become x plus 5 equal to 0. And let's do some linear algebra. It will become x is equal to negative 5. And so we have it. The line at x equal to negative 5 will be our vertical asymptote. And as for our horizontal asymptote, we got several different cases. Horizontal asymptote actually depends on the powers of the overall function. For example, if the power of the function on the denominator part is greater . is greater than the denominator, it will become infinity. So which means this graph doesn't have a horizontal asymptote. If my power on the numerator is less than the denominator, the horizontal asymptote will be 0. If the power of the numerator equals to the denominator, the graph will be the ratio between them. So let's say we have a function, we have a ratio of 2x cubed over 3x cubed, and that means that because the power of the numerator and denominator side they're the same, so our horizontal asymptote would be 2 over 3. And let's add some example for the first one and the second one. For power in the denominator is greater than the denominator, will be something like 2x cubed over x, etc., etc. Or 2x cubed over x, yeah, just 2x. And it will become just positive infinity. And then as for the power of the denominator is less than the denominator, we can do something like 1 over 3x, and this will become 0. Because as the number of the denominator gets bigger and bigger, this entire horizontal asymptote is closer and closer to 0. So let's refer back to the question and see what does the power on that look like. The power on that is the same, so which means we have a horizontal asymptote of 3. So become y is equal to 3. Let's say like here. And then we also have a whole of 2 comma 12 over 7. 2 comma 12 over 7. So it will be about like here to something like here. And then we also need to identify the 0. The 0 is just how to make this function, the denominator part becomes 0. And here, the last part of it is this, x plus 2. So which means that when x is equal to negative 2, this function will become 0. So here. So how do we graph this? Usually, when we have a whole and a 0 together, we'll try to connect them. And we'll be very close to our horizontal asymptote and vertical asymptote, but we never touches it. And the other part will never be on the side of it, but rather as an opposite side of it. So it'll be something like this. The last calculus fundamental I will cover is trigonometry. You'll be using many trigonometry while you're learning calculus. Therefore, it's important for us to understand the characteristics and features of each trigonometry function, such as sine, cosine, and tangent. So let's do some recap on what are those. So here I have a triangle, and I have an angle called theta, and I will mark the opposite side of it x, and the hypotenuse y, and the adjacent side z. And the first one is sine. The sine of theta, which is the angle from here, will be equal to opposite over hypotenuse. So become x over y. And the cosine of theta will be adjacent over hypotenuse, which will become z over y. The tangent side will be opposite over adjacent, so it will be up over ADJ, which will become x over z. And there's also another three that are the reciprocal of these three functions. The first one, corresponding to sine, will be cosecant, which will be just basically y over x. The second will be secant theta, which will be y over z. And the last one will be cotangent of theta, will become z over x. And there's an acronym we all have learned in middle school or high school freshman year to remember all of these. It is SOHCAHTOA. Sine opposite over hypotenuse, and cosine adjacent over hypotenuse, and tangent opposite over adjacent. SOHCAHTOA. So next we'll be practice using those functions with a couple practice problems, as well as introduce you to some newer ideas. So here I have a triangle, and let's say I have 45 and 45 degree here, and 45, so that makes this angle 90. And what is this triangle? Please pause this video and try it yourself. This triangle is an isosceles triangle. Therefore, it means that this side is congruent to this side. So let's say I have a side of this called 1, and this side will be called 1 as well. And here, this longer side, what is this side? This side will be, using the Pythagorean theorem, will be 1 squared plus 1 squared is equal to c squared. So it will become 2 and equal to c squared, and c will be square root 2. So this will be square root 2. So now let's try with other different numbers. Let's say I have like 3 squared plus 3 squared and is equal to c squared. 3 squared plus 3 squared is 9 plus 9 will be c squared. And then 9 plus 9 is 18, c squared. And then the square and then c will be the square root of 18. And 18 can be further simplified into 9 times 3, so 2, so become 6, become 3 root 2, something like that. So it will become, so the formula for these 45, 90, 60, 45, 90, 45 degree triangle will be the side length is equal to x, and then the hypotenuse length will be x root 2. And if I want to use sine on this triangle, what will it be? Let's say I want to use it on this 45 degree. So sine of this 45 will be so O over H, which will be 1 over root 2. And we want to make it rational. So when we multiply it by root 2 and root 2, it will become root 2 over 2. And let's say if I want to use cosine 45. Cosine 45 will be A over H, 1 over root 2, same as sine 45, and we also want to make it rational, and it will become root 2 over 2. And the last one is tangent 45. Tangent 45 will be tau O over A, which is just 1 over 1, and which is just 1. So now we know that sine, cosine, and tangent of 45 are root 2 over 2, root 2 over, oh, this looks too bad, sorry, will be sine, cosine, and tangent of 45 degree will be root 2 over 2 and root 2 over 2 and 1. So now let's look at another triangle. This time we'll have something like this. Oh. This one will be a 90 degree, and this will be a 30 degree angle, and this will be 60 degree. So let's mark this side 1. And what is the side of the hypotenuse? So right now you may not figure this out. However, if I make another triangle like this, becomes 60 and 60 and 30 and 30, and these are the right angles, you will notice that this is actually an equilateral triangle, which means that all of the sides will be 1 and 1, because the bottom is 1 plus 1, which is equal to 2, and the other two sides will be 2. So which means that here will be 2. And using the Pythagorean theorem, you can use 2 squared minus 1 squared is equal to 3, and we have to square root it. And so C, which is the other side, will become square root of 3. And similarly for the other 45, 90, 45, the sides rule of these, the general size rule will be the shortest length, or the one next to the 90 degree angle, will be x, and the other side will be 2x, and the last but not least, next to the 30 degree angle, will be x root 3. So now let's say if I want to do sine 60 and cosine 60 and tangent 60. So sine 60, we know that is so O over H, and so O over H in this side will be root 3 over 2. Will be root 3 over 2. And cosine 60 will be ca A over H, will be 1 over 2. And tangent 60 will be tau O over A, which will be root 3 over 1, which is just root 3. So now let's fill in the table. Oh, where's the 1? So now let's say if I want to do sine 30, cosine 30, and tangent 30 with this triangle, with this angle, become sine 30, one sec, sine 30, cosine 30, and tangent 30. So sine 30, using the rule, we know will be, so O over H will be 1 over 2, 1 over 2, and cosine 30 will be ca A over H will be root 3 over 2, and tangent 30, so O over A, 1 over root 3, 1 over root 3, and once again we need to make it rational, so multiply by root 3 and over root 3, and it will become root 3 over 3. So here we have 1/2 and root 3 over 2, and tangent will be root 3 over 3. So here is actually the basics of unit circle. The unit circle is on a circle, and I have some grids, and here will be 1, and here I'm gonna make a triangle, and this side will be 1, and this side will be some angles. Does this sound similar to you? Oh, this is actually 30. One sec. So right now, by knowing these angles, I can know that when 30, it'll be 1/2. The radians will be 1/2, and in 45, the value will be root 2 over 2, etc., etc. And there is a way to remember this, and I have also included this in my previous video, which is I can draw a big square root sign, and I will say 1, 2, and 3. The next row I'm going to say 3, 2, and 1, and then I'll say over 2. And here I will say sine, here I will say cosine, and here and on top I will say 30 degree, 45 degree, and 60 degree. So here, when it's sine 30, it will be root 1 over 2. When it's cosine 45, it will be root 2 over 2, and etc., etc. So now you have mastered unit circle. And that said, you have also mastered some of the very, very basic skills of calculus. So let's do a recap on all of those we have learned in this video. So this first thing we have learned is the general difference quotient equation. General quotient difference equation, which is f of x plus h minus f of x over h. And the second thing we learned are how to identify vertical asymptotes and horizontal asymptotes. As for horizontal asymptotes, we know that if the denominator is greater, the power of the denominator is greater than the denominator, we'll have a positive infinity horizontal asymptote, which means there's no horizontal asymptotes. If the power of the denominator is smaller than the denominator, then it will be 0. And if they're the same, it will be the ratio of them. And so the last thing we learned are the trig. The trig, we know there's now a faster way to remember the unit circles, which will be 1, 2, 3, 3, 2, 1, and over 2. And also I forgot to mention about the tangent. The tangent is basically tangent of theta is equal to sine theta over cosine theta. So anything you have on this graph, you can just divide them. And with that said, we also learned the acronym to remember sine, cosine, and tangent. It will be SO, CA, TOA. Sine is